All right, next, part 2 of 3.5E is called complex fractions. What is a complex fraction? A complex fraction is a fraction or fractions within a fraction. That's what it is. It complicates things, right? So you end up with a fraction within a fraction or fractions within a fraction. And what that means, basically, you want to simplify your numerator down to one single fraction. And again, that's by using LCD rules. And we're going to learn a little shortcut when they're small. And then we're going to simplify the denominator down to a single fraction. And then after that, it becomes to divide, which is keep, change, flip, right? Multiplying by the reciprocal, okay? And then you simplify, eliminate if possible, and then state any restrictions on the variables, okay? All right, stating restrictions on the variables is going to be very important for this one because, again, you have multiple fractions that you're dealing with, okay? So a good thing to start off with is to acknowledge your fractions in the very beginning also. So if you look right here, we have 1 over x plus 3 and 5 over y plus 4. So based on what we have right here, we can already say what x and y can't be currently, right? Yes? Does that make sense? Because if they're in the denominator, what's going to happen? It doesn't work. So looking at what we have right now, what can x currently not be? 0. X currently can't be 0 and y can't currently be 0. Does that make sense? Yes. Because if I plugged in 0 to either one of these, it would blow up my problem, right? It would be undefined. Okay. All right, we're going to learn a little shortcut to finding an LCD. Well, not an LCD, but a common denominator, okay? So we're going to start with our numerator. So for our numerator, we have 1 over x plus 3 over 1. Because we talked about if there is no denominator, who's there? 1. Casper the friendly 1. All right, I like to call this chopsticks in a bowl, okay? My teacher called it bats and ball, but I thought that was dumb. So, or bats in a bag or whatever she called it. Anyway, I call it chopsticks in a bowl because it looks like chopsticks to me in a bowl. All right, so 1 times 1 is 1. Your rice is your operation plus x times 3 is 3x all in the bowl. X times 1 is x.
I think it looks like a baseball bat.
It looks like chopsticks in a bowl.
There you go. 5.
Left to right. You cross multiply left to right. So 1 times 1 plus x times 3. Because it was 1 over x. And then x times 1 is? You multiply the denominators. Okay. This trick works anytime. So if you had 1/2 plus 1/4, it does the same thing. 1 times 4 is 4 plus 2 times 1 is 2, all in a bowl, over 8, which gives you 6 over 8, which equals 3 over 4. Okay, if you want to be bats in a bag person, go for it. But I see chopsticks in a bowl, so I'm going to keep saying chopsticks. All right, we're going to do the same thing to our denominator, okay? So our denominator, we have 5 over y plus 4 over 1. 5 times 1 is 5. My rice is positive. Y times 4 is 4y over y. Okay, now what happens is this is your numerator, this is your denominator. So I'm going to rewrite it just so you can see it all together. But so the problem now, this equals 1 plus 3x over x all over 5 plus 4y over y. And now this is where you keep, change, and flip. But once you already have it separated, I like to remember keep, change, flip from here, because this is saying this divided by that, right? So we're going to keep, change, and flip. So we have 1 plus 3x over x times y over 5 plus 4y. And when you multiply, you just multiply straight across, right? If you're not good at multiplying, distributing out like just normally, you can write it all out. So we have y times 1 plus 3x over x times 5 plus 4y. So my final quotient is distribute. We get y plus 3xy all over distribute, 5x plus 4xy. And that is your quotient. Okay, from here, we also realize that there's another restriction on our domain. And that's right here. We already know x can't equal 0, but what happens to this guy?
Wait, where's the 9?
5 plus 4y.
Oh.
So y cannot also equal negative 4 over 5. It's a y. It's 5 plus 4y. Mhm. So remember, when you're looking at your denominators, you're saying what would make my denominator equal to 0, right? Well, we already know we can't be x. That was one of the first things we stated, right? But now we're down to 5 plus 4y. So if I have 5 plus 4y equal to 0, what do I need to do to get y by itself? We would have to, I wrote it upside down. You saw nothing.
I was gonna say, I said 5 over 4.
Yeah, I was like, wait, I wrote that upside down. There we go. I would have to subtract the 5 and divide by the 4.
Yeah.
Okay, so this is an example of the biggest it would get. For the most part. Yeah, this would be the biggest it would get.
That's a lot to remember.
Just remember, one denominator and the numerator, one denominator and denominator, keep, change, flip. 1, keep, change, flip.
But then there's extra steps, that you're like, oh, but this one's different when we do this here.
Oh,
And like,
it's the same.
then I forget that later.
I see it. All right, so again here, this is a easier one. Because your numerator is just a whole number, right? I don't need to do anything to it. It's good to go. It's done. But my denominator is not. So looking at our current denominator, what is our restriction that we already have? X cannot equal 0.
We have to do rice in the bowl.
Yes. Yes.
Well, there's also rice in the bowl. There's also rice.
There's also rice. Okay, or bats in a bag. However you want to do it, but
That's bad. Sounds good.
all right, here we go. Chopsticks in a bowl sounds great to me. 5 times 1 is 5 plus x times y is xy all over
Oh, man.
X.
Cancel out the X or no, it's not one like
You
that.
cannot cancel out the x. Remember, you cannot cancel out across addition and subtraction. Okay, so the problem is we have negative 3 over 1. We're going to keep, change, and flip, right? Negative 3 over 1. We're going to change the multiplication, and we're flipping this guy, right? This is what we're flipping. So we have x over 5 plus xy.
That means the y that equals to 0, because if it's 0, you multiply to x.
Yes and no. We're going to talk about it in a second. Well, good question. All right, so we have negative 3x over 5 plus xy. That's a weird looking plus sign right there. All right, so now we're down. This is our quotient. And Z brought up a good question. So does that mean y cannot equal 0? Right? Now, if x or y equaled 0, would it affect the 5? It wouldn't. Because I would still have the 5 standing. Does that make sense? So whether x and y are 0, it doesn't affect this because 5 would still be standing. Does that make sense? Yeah. Okay. So that's why y doesn't have any restriction because it wouldn't have any impact on it. Okay. There would be only very specific times. So like if you were to kind of think about this and point it out, if you had I don't think I'll ask you this in depth. But if it said if x equals, exactly. So if you just have to know that x times y cannot equal -5. So it's more of a combination of so x times y cannot equal -5. Does that make sense?
Yeah.
Because it wouldn't necessarily be 0 that would be the problem. It would be if they equaled -5.
So if you have like one of them was half and then it was negative.
Exactly. Any combination of, yeah, would be the problem.
We done?
Okay. All right. The last one is as easy as it gets. So the last one is showing you what it looks like if it's already one fraction in the numerator and one fraction in the denominator. What do you have to do? Keep, change, flip. There's nothing else you would have to do. So this would be a level 1 complex fraction. Everything is done for you. You just have to keep, change, and flip. Before you do that, state your domain restrictions. What can x not equal here?
0.
-2
-2.
and +1. Because if I plug in -2, it makes the numerator 0. If I plug in 1, it makes the denominator 0. Do we see that?
Wait, what's the numerator and what's the denominator?
So your numerator fraction is here.
So they're all numerator except for the bottom one?
Yeah, so you have a numerator fraction and a denominator fraction. That's what makes it complex.
So 3 is the denominator.
The 3 is part of your denominator. Yeah. So we have 4 over x plus 2. We keep. We're going to change from division to multiplication, and we're going to flip, and it becomes x minus 1 over 3. And now it's just straight multiplication. 4 times x minus 1 over 3 times x plus 2. And what do we get?
4x minus 4 and 3x plus 6.
And we get 3x plus 6. And that -2 already satisfies that restriction. Does that make sense? So that would be the simple one. All right, that is complex.
I hate it.
I know.